Astronomers are discovering exoplanets falling apart in space at a cataclysmic rate. Astronomers found two planets around two separate stars that are succumbing to their star's intense heat. Both are disintegrating before our telescopic eyes, leaving trails of debris similar to a comet's. Both are ultra-short period planets, USPs, that orbit their stars rapidly. These planets are the rare subclass of USPs that are not massive enough to hold onto their material. Astronomers know of only 3 other disintegrating planets. USPs are known for their extremely rapid orbits, some completing an orbit in only a few hours. Since they're extremely close to their stars, they're subjected to intense heat, stellar radiation, and gravity. Many USPs are tidally locked to their star, turning the star-facing side into an inferno. USPs seldom exceed 2 Earth radii, and astronomers think about 1 in 200 Sun-like stars has one. And they were only discovered recently and are pushing the boundaries of our understanding of planetary systems. There are plenty of unanswered questions about USPs. Their formation mechanism is unclear, though they likely migrated to their positions rather than formed there. They're difficult to observe because of their proximity to their stars, making questions about their structure difficult to answer. Fortunately, 2 separate teams of researchers have spotted the 2 disintegrating USPs. As they spill their contents out into space in tails, they're giving astronomers an opportunity to see what's inside them. The new observations are in 2 new papers available at the preprint site ARXIV. One is a disintegrating rocky planet with prominent comet-like tails around a big star. And the author is Mark Hahn, a postdoctorate researcher at MIT Test Science Office. This paper is referred to hereafter as MIT study. And we report the discovery of BDX, I'm not going to go into the numbers, a transiting exoplanet orbiting a bright K dwarf with a period of only 1.27 days. The author writes, the TESS spacecraft found the planet and its observations reveal variable transit depths and asymmetric transit profiles, the paper says. Those are characteristics of dust coming from the doomed planet and forming tails, one on the leading edge and one on the trailing edge. Dust particle size in each tail is different, with the leading tail containing larger dust and the trailing tail containing finer grains. The rate at which the planet is evaporating is utterly cataclysmic, and we are incredibly lucky to be witnessing the final hours of this dying planet, Mark Hahn said. The disintegrating planet orbiting BD plus 05 has the most prominent dust tails to date, said the author. The dust tails emanating from the rapidly evaporating planet are gigantic. Its length of approximately 9 million kilometers and circles over half the planet's orbit around the star every 30.5 hours, he said. The MIT study shows that the planet is losing mass at the rate of 10 Earth masses of material per billion years. Since the object is probably only roughly the size of Earth's moon, it will be totally destroyed in only a few million years. The rate at which the planet is evaporating is utterly cataclysmic, and we are incredibly lucky to be witnessing the final hours of this dying planet, says Hahn. The host star is probably a little older than the Sun and has a companion red dwarf, separately about 130 AUs. The authors think that the planet is a great candidate to follow up studies with the James Webb Telescope. Not only is the star bright, but the transits are deep. Because of the leading and trailing trails, the transits can last up to 15 hours. The brightness of the host star, combined with the planet's relatively deep transits, presents as a prime target for compositional studies of rock, exoplanets, and investigations into the nature of catastrophically evaporating planets. What's also highly exciting about BT plus 505 is that it has the brightest host star out of the other disintegrating planets, about 100 times brighter than K222, establishing it as a benchmark for future disintegrating studies of such systems. Prior to our study, the 3 other known disintegrating planets are around faint stars, making them challenging to study, he said. Now, this work, astronomers, in this work, they were able to observe the debris with the James Webb MIRI, and also with other telescopes. The observations show that the material coming from the USP is not likely to be iron-dominated core material. Instead, they're consistent with some form of magnesium silicate minerals, likely from mantle material, the authors explain. These planets are literally spilling out their guts into space for us. With James Webb Telescope, we'll finally have the means to study their composition and see what planets orbiting other stars are really made of, the lead author Tussi says. We cannot see what's inside the planets in our solar system through seismic waves, and other observations give scientists a pretty good idea about Earth's interior. By examining the entrails coming from K222b, astronomers are learning not only about the planet, but by extension about other rocky planets. The irony is that they are also so far away. K222b has an asymmetric transit profile, and the planet's dusty cloud of affluence comes into view in front of the star, showing evidence of extended tails like a comet. It's a remarkable and fortuitous opportunity to understand terrestrial planet interiors, Professor Jason Wright, Astronomy and Astrophysics, Penn State, says. And while TESS discovered the disintegrating planet in the previous paper, Kepler found this one during its extension K2 mission. This one orbits its M-dwarf star in only 9.1 hours. Evidence of its tail is in the variability of its light curve. The dramatic variability in light curve transit deepened depth combined with the asymmetric transit shape suggests we are observing a transient cloud of dust subliming off the surface of an otherwise unseen planet. According to the authors, this cloud could be the first time we've seen outgassing from a vaporizing planet. The shorter MIRI wavelength features may constitute the first direct observations of gas features from an evaporating planet, the paper says. You can see they're very excited about this. It's a very long article, but this is from Universe Today by Even Go on Science Alert. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.